A Boeing 747 fuselage was so large it could make an ordinary aircraft factory look like a garage. In the mid-1960s, Boeing was trying to build the first true jumbo jet, a double-aisle airliner with 2 decks at the front, 4 engines under the wings, and enough room to carry hundreds of passengers across oceans. But before that airplane could roll onto a runway, Boeing faced a stranger problem. It did not have a building big enough to assemble it. The parts were enormous, the tooling was enormous. Even moving sections of the airplane indoors became an engineering challenge. So Boeing went looking for space and found it north of Seattle in Everett, Washington, where forest and wetlands would be cleared for one of the largest enclosed volumes on Earth. This was the hidden first step of the jumbo jet era, not just designing the 747, but creating a place where it could physically exist. Was Boeing building an airplane inside a factory, or building a factory around an airplane? The 747 began as a bet that air travel would grow faster than the airports built to handle it. By the mid-1960s, jetliners had transformed commercial aviation. Aircraft such as the Boeing 707 carried passengers across oceans in hours instead of days, and millions more people wanted to fly. Airport gates, runways, and maintenance facilities were still designed for smaller planes. Airlines were adding flights to meet demand, creating delays, congestion, and rising operating costs. The industry needed a way to move hundreds of passengers at once. Pan Am saw the opportunity before most of its competitors. Its leader, Wang Tripp, pushed Boeing to create an aircraft far larger than anything then in service, a wide-body jet with 2 aisles and enough seats to make each departure more productive. In 1966, Pan Am placed the launch order for 25 Boeing 747s, worth roughly $525 million. That order gave Boeing, a customer, a vote of confidence and a deadline. The risk was enormous. Boeing was not merely stretching an existing design, it had to develop a new fuselage, new wings, new landing gear, and engines powerful enough to lift the heaviest commercial aircraft ever attempted. The development bill climbed toward $1 billion, a staggering commitment for a company that could not be certain airlines would fill so many seats. Supersonic passenger aircraft also promised faster travel, potentially making a huge subsonic jet obsolete before it paid for itself. Pan Am wanted its first aircraft in service by 1970, leaving Boeing only a few years to design, test, and manufacture an entirely new class of airliner. Every delay threatened penalties, airline confidence, and Boeing's finances. The company accepted the gamble because the reward was larger than one successful airplane. If the 747 worked, it could redefine the economics of long-distance travel. The aircraft still had to become a physical product. Boeing's existing factories and assembly methods were built around much smaller aircraft. They could not handle a fuselage of this diameter, wings of this span, or the tooling required to build them at commercial scale. The design had created a second problem. Where could Boeing make it? The first commercial wide-body airliner was being designed before Boeing had a building large enough to contain it. The 747 needed a massive fuselage, wide enough for 2 aisles and a high-capacity cabin, yet its most recognizable feature rose above that cylinder, the distinctive upper deck hump. That shape gave the aircraft its profile, but it also created new structural joints, stairways, wiring routes, ventilation systems, and interior equipment to fit into the design. This was an engineering project on an industrial scale. Tens of thousands of Boeing employees worked across design, stress analysis, systems, production, and tooling. Their plans eventually filled more than 75,000 engineering drawings. Each drawing specified more than an airplane's shape. It fixed dimensions, materials, fasteners, access points, tolerances, and the order in which thousands of parts would meet. The wings were so large that Boeing had to consider how workers could reach them, how fixtures would support them, and how completed sections could move through the factory. The fuselage could not simply be built as one enormous tube, so engineers divided it into sections and designed the joints between them. The landing gear had to carry the aircraft's immense weight, retract cleanly, and leave room for fuel, structure, and cabin systems. The engines demanded stronger pylons, larger fuel lines, new maintenance access, and equipment capable of handling their size. Even assembly flow became part of the aircraft's design. Stations had to be arranged so that a fuselage section could enter, receive wiring and plumbing, join with its neighbours, and continue forward without blocking another team. Massive jigs and lifting tools had to hold parts accurately while workers drilled, fastened, inspected and sealed them. A small change in one location could force changes through the entire sequence. On paper, Boeing could revise a drawing, move a joint or resize a tool. In the real world, steel, concrete, cranes and buildings had to be committed before the first 747 could take shape. That meant Boeing could not solve the 747 with a bigger version of an existing plant. The aircraft needed a building wide enough for its fuselage sections, wings, tooling, cranes and sequential assembly stations. Those stations also needed enough clearance for workers and equipment to move around the airplane without interrupting the next one in line. Boeing's current facilities simply did not provide that volume. Location mattered as much as floor space. The new plant had to sit close to a runway because large aircraft and oversized components would need direct access to air transport. It also needed roads, utilities, worker access and enough surrounding land for parking, loading, storage and expansion. Boeing was not planning a temporary shed for one production run. It needed an industrial base that could grow with the 747 program and whatever aircraft came after it. In 1966, Boeing bought more than 750 acres near Paine Field in Everett, Washington. The site offered the critical combination: an airport next door and enough territory for a factory on an unprecedented scale. Its distance from Boeing's established production centres was a complication, but the available land made the move possible. There was one enormous catch. The property was not waiting for an assembly plant. It was still forest, hills, mud and wilderness. Before a fuselage section could enter a production station, crews would have to clear trees, cut down slopes, fill low ground, stabilise the soil, build roads, install drainage and utilities, and create foundations strong enough for the building and its cranes. The 747 had started as an aviation problem. At Everett, it became a construction problem first. Boeing now had to transform raw land into the factory that would make the aeroplane possible. That transformation began with a construction operation large enough to look like its own industrial project. Crews cleared hundreds of acres of timber, opened access roads, and removed the hills that interrupted the future building site. Where the ground fell into valleys, earth was pushed in and compacted. Where slopes stood too high, crews blasted and cut them down. Every foundation pad had to be level and stable before the factory steel could rise. The future floor would carry assembly tooling, cranes and completed aircraft, so grading alone was not enough. Fill had to be compacted, drainage had to be installed, and the soil had to be tested before concrete could lock the site in place. Boeing divided the work among roughly 250 contractors. More than 2,800 workers operated bulldozers, excavators, trucks, drills, and blasting equipment across the property. Their first objective was not the building itself. It was making the site behave like a building site, reshaping the terrain, controlling water, laying utilities, and preparing access for the materials that would eventually form the plant. Transport became a project within the project. A 5-mile railway spur was built to bring in heavy equipment and construction material, linking the remote site to the regional rail network. That connection mattered because the factory would consume material on a scale ordinary roads could not efficiently support. Before production could move an airplane through the building, rail cars had to move steel, concrete and machinery into the clearing. Weather repeatedly slowed the schedule. Rain turned graded ground into deep mud and made hauling difficult. Windstorms damaged temporary works and disrupted crews. Mudslides threatened roads and slopes. Snow added another layer of delay, freezing surfaces that had already been difficult to stabilise. Work continued, but a single storm could erase days of progress. This was not a neat sequence in which one phase ended before the next began. Crews were clearing forest in one area, filling low ground in another, and installing infrastructure needed to support both. The land had to be reshaped while the factory's design, tooling and aircraft assembly plans advanced elsewhere. Around 2,800 workers were therefore racing weather and schedule at once. Every week spent preparing the site consumed time from the 747 program itself. The airplane's development clock was already ticking, and Boeing had not yet built the room where the first one would be assembled. The construction schedule left Boeing with a problem that was almost absurd. The first 747 could not wait for a perfect, finished factory because the airplane itself was already on a deadline. So Boeing began using the Everett plant while the plant was still becoming a plant. On January 3, 1967, the first 113 assembly workers reported for 747 production. They were not walking into a polished final assembly hall with every system complete. They were entering a huge construction site that had only begun to function as an aircraft factory. Parts of the building were enclosed, other areas were still being finished, utilities, cranes, tooling, roads and workspaces were all coming together around them. The early structure already showed why this factory was different from anything Boeing had built before. The first 3 steel sections were each roughly 300 feet wide and 1,000 feet long. A single one of those sections was the size of a major industrial building. 3 of them side by side were only the beginning of the space needed for the 747. Inside that unfinished shell, assembly work had to begin in pieces. Crews installed tooling, organized work areas, and prepared for the first major fuselage sections while construction crews kept expanding the building. The usual boundary between a construction project and a production line disappeared. In one part of Everett, workers were creating the factory. In another, workers were starting the airplane that justified the factory's existence. That overlap created a management challenge with almost no margin. If a tool arrived before its foundation was ready, it had nowhere to go. If a section of the building lagged behind, aircraft work could back up behind it. If utilities were late, new production areas could not come alive. The program needed thousands of separate tasks to land in the correct order, even though the building itself was still changing every week. Boeing was now committed on 2 fronts at the same time. The 747 had to become a real airplane, and Everett had to become a real factory quickly enough to build it. Either failure would threaten the other. If the aircraft program stumbled, the massive new plant would become an expensive gamble with no payoff. If the factory fell behind, the airplane could miss the schedule that made the whole program viable. From this point on, Boeing was not simply building the world's largest factory for one airplane. It was betting that both could be finished before either one broke the plan. Inside Everett, the 747 did not look like an airplane at first. It looked like a city being organized into aircraft parts. The original plant enclosed roughly 200 million cubic feet of space, already an almost impossible number to picture. Later expansions pushed it to about 472 million cubic feet, making the Everett factory the largest building in the world by volume. That title was not won with height alone. It came from the amount of uninterrupted indoor space Boeing needed to move an airplane this large through production. A fuselage section could arrive as a giant metal cylinder, already taller than the people working around it. Wing structures stretched across tooling fixtures like bridges laid on their sides. Landing gear stood near workers like industrial sculptures, with tyres large enough to make a mechanic look misplaced beside them. The factory turned ordinary human scale into a measuring tool. If a person looked tiny, the part was probably for the 747. The work moved through a sequence of stations. Major fuselage sections were positioned, aligned and joined. Wings were brought into place with exacting tolerances because a small error at the root could become a much larger problem across the full span. Engines, systems, interiors, wiring, hydraulics and flight controls entered the process at different points, each one tied to a schedule that had to match the aircraft moving down the line. Above all of it, cranes carried the parts that people could not. These were not background machines. They were part of the production system, moving sections overhead while crews below prepared the next operation. For a moment, it is worth hearing what that kind of factory movement feels like. That sound was the plant doing its job. Everett was not just a big empty box with airplanes inside. It was a controlled environment where cranes, jigs, platforms, scaffolding, tools and workers all had to meet the airplane at the correct height, angle and moment. The scale also changed the rhythm of labour. A worker might spend a shift inside one section of the fuselage, installing systems in a space that would later be only a small part of the finished jet. Another crew could be far away on the same aircraft, working near a wing or tail structure separated by distances that felt more like a warehouse than a single product. From outside, the 747 was one airplane. Inside Everett, it was thousands of coordinated zones, each with its own task, its own tooling, and its own deadline. The genius of the building was not simply that it could contain the jet. It allowed Boeing to turn a machine of unprecedented size into a repeatable assembly process. The production system inside Everett had to work because Boeing had already crossed the point where turning back was realistic. By the late 1960s, the 747 was not a cautious experiment. Boeing had taken orders from major airlines, built a dedicated factory, expanded its workforce, and committed huge amounts of money before the first airplane had proved itself in service. Pan Am, the launch customer, wanted the jet quickly, and other airlines were watching closely. Every promise Boeing made on delivery dates became pressure on the factory floor. The financial risk was unusually concentrated. The airplane needed the building because no existing Boeing plant could produce it at the required scale. The building needed the airplane because without the 747 program, Everett was an enormous investment with no immediate purpose. A delay in construction could slow aircraft assembly. A delay in aircraft design could leave a finished production line waiting for parts, drawings, or tooling that was still changing. That is what made the schedule so dangerous. Boeing was not finishing a design, then calmly building a factory, then slowly training a workforce. Much of it happened at the same time. Engineers were still solving problems while production teams were planning how to build the solutions. Construction crews were still completing parts of the plant, while manufacturing crews prepared to move aircraft sections through it. The 747 also forced constant coordination with suppliers. Engines, avionics, hydraulic systems, landing gear, cabin equipment, and thousands of smaller components had to arrive on time and fit an aircraft that was still evolving. If one major supplier slipped, the delay did not stay isolated. It could stop work at a station, create rework, or force Boeing to store partially finished sections while waiting for missing pieces. Airlines added another kind of pressure. They were not buying the 747 as a museum piece. They were planning routes, passenger capacity, crew training, airport operations, and publicity around a jet that promised to change long-distance travel. Boeing had to deliver an aircraft, but it also had to deliver confidence. So Everett became more than the world's largest factory. It became a bet made out of steel, concrete, payroll, and deadlines. The company had invested in the airplane. The airlines had invested in the promise, and the factory had been built around a machine that still had to prove it could leave the ground. The question now was simple. After all that money and pressure, could the first 747 actually roll out of this giant new building? On September 30th, 1968, Boeing opened the giant doors at Everett and let the world see what the factory had been built to create. The first Boeing 747 did not appear like a normal new aircraft. It moved out of a building so large that the airplane still looked like part of the structure behind it. The nose emerged first, with its raised upper deck, giving the jet a shape no passenger aircraft had ever had. Then the full scale became obvious. A wide-body fuselage, 4 engines, a tail towering over the crowd, and wings stretching across the rollout area. Around it stood thousands of Boeing workers, many of whom had spent months turning drawings, tooling, and unfinished sections into a complete airplane. Airline representatives were there too, because this was not just Boeing showing off a prototype. 26 airlines had already placed their names on the program, and for the rollout, their logos were displayed on the aircraft, turning the jet into a flying promise of global cooperation. In that moment, the Everett factory and the 747 became the same story. The building had not been a backdrop, it had made the airplane possible. Its height, floor space, cranes, assembly positions, and production flow had all been designed around getting this one enormous machine from loose parts to a finished airframe. The spectacle mattered because the risk had been so visible. Boeing was proving that the new plant could do what it was supposed to do: receive massive components, bring them together, support a huge workforce, and produce an aircraft at a size the industry had never handled before. The airplane rolling into daylight was the factory passing its first public test, but rollout was not the same as success. The 747 still had to fly. On February 9th, 1969, the first aircraft lifted off from Paine Field for its maiden flight, carrying the program into the next phase of testing. By then, Everett had already done something remarkable. It had turned an unfinished industrial gamble into a real airplane. Now the question moved beyond construction and engineering. If the 747 worked, it would not only change Boeing, it would change who could cross oceans, how many people could travel at once, and what long-distance flight meant for the modern world. The maiden flight answered whether the 747 could fly. The harder question was whether Everett would remain useful after Boeing delivered the first orders. It did. Production continued at Paine Field for more than 54 years, and the factory became Boeing's permanent wide-body centre. 1,574 Boeing 747s were built there, from the first production aircraft to the final jet delivered to Atlas Air in 2023. During that time, Everett did not stay frozen around the original design. Boeing extended the building, added assembly positions, installed new cranes and tooling, and reorganised its floor to handle newer aircraft. The expansions made the factory even larger, allowing it to support the 767, 777 and 787 programs alongside the 747 at different points in its history. But growth can make the building story seem broader than the airplane that started it. But the sequence matters. Boeing did not first decide to create the world's largest factory and then search for a reason to fill it. The 747 created the need for the height, the span, the lifting capacity, and the enormous uninterrupted floor. Every later expansion built on that original decision. When the last 747 left Everett, the production line closed, but the building remained a working monument to the jet's impact. It had outlived the program's early risks, absorbed generations of aircraft, and helped make wide-body production a permanent part of Boeing's identity. Boeing did not simply build the 747 inside Everett. The 747 forced Everett into existence. That is the scale of Boeing's gamble. The 747 demanded an industrial world before it could become an everyday aircraft. In response, Boeing created two landmarks at once, a revolutionary wide-body airliner and one of the largest buildings ever constructed, designed around its wings, weight and production rate. Thank you for watching. If you want more stories about aviation mega projects, subscribe to the channel. Tell us in the comments which aviation mega project we should cover next. The 747 changed the sky and changed the ground beneath it.